All right, a couple of you had asked if I could go through a solution to written response number 1 on the Unit 3 review booklet 2, where you're asked to determine the equation of a tangent line to a function at a particular point. Remember that when you are trying to determine the equation of a tangent line, which is a straight line, you need to use the formula y minus y1 equals the slope times x minus x1. And of course, y and x are the variables. The parameters that we need to load into this are y1, x1, and the slope of the line. So let's start off with the calculus aspect of this question. The slope of the line is going to be the value of the derivative of the function at the x coordinate of 1. In terms of x1 comma y1, that's the point of tangency. So we already know the x coordinate. The x coordinate is 1. To find the y coordinate, what we can do is calculate f of 1. So this is f of 1, which kind of makes sense. If you know the x coordinate, you want to find the y coordinate, then you have to put x into the function. The function's in the top left corner. Let's see what we get. We get f of 1 is equal to 1 over 2e to the 1 minus 2 ln 1. Now, the natural logarithm of 1 is the exponent to which you raise e to get 1, which means it's 0. And if the natural logarithm of 1 is 0, then this whole term is 0. And what you're talking about for a y coordinate is simply 1 over 2e. So now we know x1, we know y1, we have to work on finding the slope. Let me rewrite the original function. The original function is f of x. I'm just going to write y equals, and I'm going to write this as 1/2 e to the negative x to make differentiating that first term easier. E to the x in the denominator of a fraction is the same as having e to the negative x in the numerator. Then we have minus 2 ln x. I haven't differentiated anything yet. If I differentiate now, I'm going to get the following. dy dx is, okay, so what is the derivative of a base e exponential term? It's the base e exponential term multiplied by the derivative of the exponent of the argument of the exponential function. Now the exponent is negative x. The derivative with respect to x of negative x is negative 1. So I'm just going to put a negative in front of the 1/2. Minus 2 times, now what is the derivative of the ln of x? It's 1 over x. So this is what we have for our derivative. I'm going to rewrite this without the negative exponents so that we can use it in our next step. This is negative 1 over 2e to the x minus 2 over x. Now don't forget, we're using this to determine the slope. The slope of the line will be equal to the derivative of the function which we've found evaluated at the point of tangency. So that means I need to put 1 in for x in my derivative, and I'm going to get negative 1 over 2e to the 1 minus 2 over 1, which means I get negative 1 over 2e, and then minus 2. So this is our slope. To summarize things, we have our slope, and we also have y1 being, I believe it was 1 over 2e. I just need to scroll up and check. And x1 being 1. So we also have x1 comma y1 being 1 comma 1 over 2e. And we need to load those three parameters, the slope and x1 and y1, into our point slope formula of y minus y1 equals the slope times x minus x1. And simplify the result. And this is where things get a little bit messy. It's not going to be necessarily simple, It's going to be quite complex, especially given the fact that our slope is a binomial. But let's put it in and see where it leads us. We have y minus y1, which is 1 over 2e. And this is equal to the slope, which is negative 1 over 2e minus 2, multiplied by x minus x1, which is 1. Well, if we want to simplify this, and I'm a fan of going to the ax plus by plus c equals 0 form, then you're going to have to FOIL out this binomial times that binomial. Let's see what happens here. We have y minus 1 over 2e is equal to, so I'm going to multiply my first, and that will give me negative 1 over 2e multiplied by x. I'm going to multiply my outer, which is negative 1 over 2e times negative 1, which gives me positive 1 over 2e. I'm going to multiply my inner, which is negative 2 times the x. That gives me negative 2x. And then finally, I can multiply out my last, which is negative 2 times negative 1, which is positive 2. And as always, I think it's a good idea to just take a breath here and double check. Looks okay. I see that I have denominators of 2e in many places. So what I would recommend here is that you multiply both sides of this equation by 2e. So I'm going to multiply this side by 2e. I'm going to multiply this side by 2e. All right, so now we're ready to multiply this through. I'm going to go 2e times y and 2e times negative 1 over 2e, which gives me 2ey minus 1. I also need to multiply the 2e here by everything in the brackets. So 2e times negative 1 over 2e multiplied by x gives, on the right-hand side, negative x. 2e times 1 over 2e gives 1. Negative 2x times 2e gives negative 4ex. And then 2 times 2e gives 4e. I'll just stand back and double check that for a second here. 2ey minus 1 minus x plus 1 minus 4ex plus 4e. I'm going to zero the equation by moving my terms to the left side where I have x plus 4ex. Then I have my y terms, which are 2ey. Keeping track of things, I've taken care of this, and I've taken care of my 2x terms. I have all of my constant terms now. I have the 4e, which when I subtract it over becomes negative 4e. I've taken care of this. I have the negative 1, and I'm going to subtract the 1 from the other side to give negative 2. This is equal to 0, and that's the answer. Taking a look at what the answer should be, I've got it pasted down here. X plus 4ex plus 2ey minus 4e minus 2 is equal to 0. So I hope that helps the couple of you that were interested in this solution, and we'll talk to you later. Have a good night.